Okay, so this is 6.8, graphing polynomial functions. I really hope you got your notes with you today, because if you don't, you're going to have a hard time keeping up. Okay, so what we have to begin to do is we have to begin to figure out how to graph a polynomial. So just look up here in the top right corner. Again, what are we talking about? Don't draw this. I'm just trying to get you to think. We're talking about graphs that maybe look like this. So that's what we're after today, is trying to understand how to graph these things, and also how to predict some tendencies of the graph and how that graph will look. So we expect something before we actually even go to graph it. So that's today's lesson. So how do we start off? Number one, the lead term, and that's the one that's the highest degree term, is used to determine the basic shape. The lead term, the highest degree term, is used to determine the basic shape of the polynomial. So we'll be able to figure out the basic shape of the polynomial, or at least some tendencies of the polynomial, by understanding the lead term. All right, so a couple examples here to get us going. All right, first off, a function with a positive lead term. A function with a positive lead term. So if you look at the example down here, it's y equals, and I stuck the 1 there, though it's usually not there, but it's a positive 1, right? If you have y equals x cubed, then it's a positive 1x cubed. All right, so you got a positive lead term. Now, this one has only one term. And remember, the lead term is the highest degree term. Okay? So, again, you don't need to write this for example. If you had something like 3x to the 6th minus 4x to the 5th minus 3x cubed minus 2, the lead term is positive. That's the condition we're talking about. I don't care about all the rest of this stuff. It doesn't matter. It doesn't bear on what we're trying to figure out right now. It's just the coefficient, the multiplier of the lead term. All right, so if the multiplier of the lead term is positive, so a function with a positive lead term will finish heading toward a positive output, which is positive infinity. That's what will happen. So if we sketch this basically looks like this. You come up from negative infinity, you cross over at 0, and you head up toward positive infinity. That's the sketch of that graph. So the output, the way this thing is ending, is toward positive infinity, right? Where is it heading? And remember, it's always left to right. So as you move from left to right, what's happening to the function? And ultimately, at the ultimate right, what is this function doing? It's heading to positive infinity. So that's what you're looking at, the ultimate right of the function. Okay, so ultimate right is what I'm talking about. All the way to the right, the far right, the far country. All right, that's what we're talking about. I'll show you a couple examples here in a minute of others. So then conversely, math is nice and orderly. So if we had a scenario where a function with a negative lead term will finish heading toward a negative output, which is negative infinity. And again, you can see there's only one term, so it's the lead term, and it's negative coefficient, and the graph of this one looks like this. Again, the ultimate right is heading to negative infinity. This thing is heading to negative infinity. All right, let me see if I can do a couple things here, make things work. Let's get rid of all that other junk. Okay. Oh, now Smart Ink's going to work? You got to be kidding me. Smart Ink did not work any other time I tested this. And now Smart Ink is going to be a smart aleck and it's going to work. All right, whatever. It's hard to find stuff. Move. Go bigger. All right, we'll just live with that. Okay, so I think this is what I want. All right, so let's suppose we had the function. You're looking here at the left. X to the 6th minus 3x to the 4th minus x squared plus 1. And again, let me see if it'll let me do ink. I guess it will. Earlier it would not. All right, we're looking right here. The interface is going to be a pain. Okay, so we're looking at x to the 6th minus 3x to the 4th minus x squared plus 1. The lead term is a 6th power term, and is the coefficient positive or negative? Positive. It's a positive 1, so you would expect this thing to end up heading toward positive infinity. So there's the graph of that. And again, the right-hand side, where are we heading? It's a positive infinity. Okay, that graph is heading off to positive infinity. Take a second function. This one might not completely fit. Let me see if I move this over even more. So you take the second one and you look at the lead term, and it's a 2x to the 5th, and it's positive again, so we should again expect this thing to be heading toward positive infinity, and that would be the graph of that. And off it goes into positive infinity. By the way, how many zeros does that function have? Therefore, if you were trying to factor this, how many binomial factors would there be? 1. That's it. There's only one possible factor. All right, that would be it on that. Let me see. Let me move some of this junk away. Okay, so what if we had y equals x to the 7th minus 2x to the 4th? And that should have been a negative. So think of that. I didn't type it in right. Y equals negative x to the 7th minus 2x to the 4th. That's what is shown right here in that graph. So again, y equals negative x to the 7th minus 2x to the 4th. Where should that thing end up? Heading to negative infinity. Where does it end up? Heading to negative infinity. And the last one, I didn't do my negative on that one either. Bummer. All right. That should be negative x to the 4th. And that's this last one here. And again, because the lead term is negative, it ends up to the right, heading to negative infinity. If the lead term is positive, it's going to end up in the right, heading toward positive infinity. If the lead term is negative, it's going to end up heading toward negative infinity. All right, so much for that. Let's get back to our notes and the next scenario. All right, C. It's going to move. All right, it stayed. All right, if the exponent of the lead term is odd, 1, 3, 5, 7, 9, 11, 13, 15, 17, right? Odd. If the exponent of the lead term is odd, the function will start and finish in opposite directions. If the lead term is odd, the function will start and finish in opposite directions. These are tendencies of every polynomial function. So if you look at the first example, you have a positive 5. And so when we take a look at this function, we say end behavior, but we're really talking about the start and finish. And this thing is going to go down and up. Now, how did I know that it started coming down and ends up? Because that's opposite. Whereas it could have started going up and end up down. That would be opposite as well, right? So you got down, up, or up, down. How do I know which one it was, Luke? Because the lead term, the x to the 5th, is a positive 1 x to the 5th. And we know that that thing ends up to the right, right? Going up to the right. So we know it ends up. Therefore, it had to start out down. It had to. If you sketch this one, this thing will look like this. And again, we're just sketching. So something about like that. Doesn't have to be perfect. Just something that gives you the concept that the start is heading down and the finish is heading up. The start is heading down and the finish is heading up. You look at the second example, and again we have an odd lead coefficient, so we know it's going to be opposite. So is it again down up, or is this one up down? This one is up down because again we know this will finish down, right? So this has to be an up down then. And the sketch of this thing, this one's kind of odd to make it look really right. So you just kind of squiggle in here. And then it never quite reaches that. Don't go quite up to there. It's hard to control on my electronic podium here. But it's something similar to that. If I actually move it down a little, it'll look a little better. It's about something like that. It doesn't have to be perfect. The whole idea is, how does this thing start and how does this thing finish? And that's really what we're concerned about. Okay, so if the exponent is odd, then the start and finish will be in opposite directions. Therefore, then, the last concept of this, if the exponent of the lead term is even, the function will start and finish in the same direction. Has to be. The lead term is even, it'll start and finish in the same direction. All right, so our first example D, let me get a little higher for you guys. First example D, is it up, up, or down, down? Up, up. Has to be up, up, right? Because our lead coefficient is positive, right? There's a positive 1 there. It has to finish up, so this thing has to be up, up. Up, up, and away. And by the way, what kind of shape is this one? A parabola. We know parabolas. And this thing looks about like that. Up, up. Second one, again, has a positive lead coefficient, right? We got an even exponent for the lead variable. So it's got to be same direction. Only now we got a negative 1 in front. It's got to finish down. So being they're the same, it's got to be down, down. Oh, the graph of this one is something about like this. Something about like that. For the down, down. All right, so far, 2 main concepts. Both involve the lead coefficient, right, or the lead term. Coefficient of the lead term positive, the graph ends up going up to the right. coefficient of the lead term negative, it ends up going down to the right. If the exponent of the lead term is odd, then the start and finish will be opposite. If the exponent of the lead term is even, then the start and finish will be the same. Two things so far. Next. All right, so again, we're talking about the lead term there. All right, the number of the directions, or excuse me, the number of directions of the function will be less than or equal to the degree. The number of directions will be less than or equal to the degree. All right, so if you look at our first example, I didn't finish the equation. Something's missing. So what's missing from that? A squared, right? This is a parabola, and that should be a y equals x squared minus 2x minus 3. So again, if you want to count directions, there's up to 2 directions. You're going down there, and you're going up there, right? You have 2 directions. Some like to say one directional change. Depends on the semantics and who's asking the question. Because it starts out heading down, right? And then there's one directional change to go up. But there are a total of 2 directions, down and then up. Okay? Let's do a few and see if it begins to make some sense. So in this example, this is a cubed. By the way, it's a positive coefficient of the lead term. We know it's going to end up going right. It's an odd exponent. It's going to be opposite, right? Down, up, and it is. And there are up to 3 directions, and this one does have 3. 1, 2, 3. Right. Starts out heading up, then it heads down, then it finishes heading up. 3 directions, 2 directional changes. Right? 3 directions and 2 directional changes. So lest you think, well, okay, that's how everything is. Remember our first examples? There's an x cubed. Up to how many directions can there be? 3. How many are there? 1. It just depends upon what the polynomial is. It can be up to 3, but this one's for always going up. There's no changes, there's only one direction. Okay, so that's why we say up to, greater than or equal to. All right, let's do a few more here. Oh, this board's going to keep doing this to me constantly. Yeah, there we go. Beautiful. Okay, so in this next example, the lead term can be up to what? Don't say it out loud. By the way, is the exponent going to be positive and negative? Positive or negative of the lead term? Which one? You can say that. It's going to be positive or negative. The exponent of the lead term. Positive or negative? Whoa. No wonder you're looking at me funny. Even or odd? There we go. All right. Even or odd? Even because of same, right? So it's a down, down. They're the same. It's going to be even. Okay, so we know it's going to be even. We expected the lead coefficient to be odd, and it is. It's a -1. So what is the possible highest that we can determine value of the exponent? It's the highest value. Think about it for a second. So again, you're just looking at the lead or the directions, right? 1, 2, 3, 4. So it's possible this is a 4. Could it be a 6? Yes. Could it be an 8? Yes. Could it be a 10? Yes. Could it be a 50? Yes. Could it be a 2? No. It can't be a 2. It's got to be at least a 4. It is a 4 that's graphed, but again, it could be more. It depends. Okay, next one. All right, so again, as we look at this, are we expecting the exponent to be even or odd? Odd, right? Because it starts out coming down on the left, it's coming down on the, it's going up, and on the right it's going down. So those are opposites. So that means it's an odd exponent. This thing should have a negative coefficient. It does, because it ends up heading to negative infinity. And the exponent has to be greater than or equal to what value? You got 1, 2, 3, 4, 5. And again, we know it's got to be odd, so it's going to be greater than or equal to 5. Again, it could be 7. It could be 9. It cannot be 3. It can't be 3. It cannot be 3. Too many directions for it to be 3. Okay, so here's one where you've got to the 7th, and that is not the graph of that. Why can this not be the graph of this? Because what's positive? What would I have to change to make this the graph? Yeah, this negative either has to not be there or be a positive, right? This thing has to have a positive coefficient to the lead variable, so it ends up to the right. It does have an odd exponent, which it's supposed to, because they're opposite directions. And this one only has 1, 2, 3 directions, but it's a 7th power, and that's possible. Okay? That is possible. Be as many directions, less than or equal to the value of the variable. Last example, that was the last one. Okay. All right, so what have we done so far? So far we're looking at the lead term. Positive or negative coefficient tells us whether it ends heading up or ends heading down. Even or odd exponent tells us whether it starts and finishes the same or starts and finishes opposite. And the value of the exponent tells us how many possible directions up to that many possible directions. Okay? That's where we've been so far. Next. So with all that in mind, let's see if we can sketch some possibilities here. It's important that we start with this first one because it's the base function. And so I'm going to go to my program here. Let me get this up. Let me go full screen. Okay, so you guys are following along in your notes right now. And so the first example is number 1, y equals x cubed. Yes? Okay. So when we look at that, how do we expect this to finish? Heading up or heading down? Heading up. Okay. Do we expect it to start up and end up, or start down and end up? Start down and end up because it's an odd. All right. So from there then, let's see if we can go ahead and sketch that. You're just sketching it. And this is the base one that we need to compare everything else to. So you're sketching that. Don't need the numbers, you're just sketching. Something that looks similar to that. This one really has no directional changes because it's, the base model. It's y equals x cubed. It's not a whole lot of other terms. It doesn't cause it to do a whole lot more. That's the situation. Okay, now look at the one to the right, a there. What's the difference? Plus 2. Is the fact that it ends up heading to the right going to change? Is the fact that it starts down and ends up going to change? Is even the shape of it going to change? So what's the 2 going to do? It's going to move it what? To right, I heard? How many agree? To right? Anybody have anything else? I just want to make sure. We're all to right? 2 up? Who are the 2 up people? Destiny. You're all by yourself. Hey, a courageous person to be all by themselves. Well, majority's always right, so of course, Destiny is not correct. Okay, there's the graph. It's up 2. I'm being sarcastic. I'm being facetious. It's up 2. Hey, think about solving the function, all right? Let me get you to think for a second so this hopefully clicks for you. And again, I wish I could draw on this thing. I'm going to try and see if it'll let me. Let me see if I can get a pen and if it'll let me. I'll probably have to go back, but we'll see. Okay, so the base, oh, it will, is that. So let's just think XY chart. When you stick in 1 for the X, what do you get for the Y? 1. But in the blue one, and again, if I could change my colors, maybe I can. Yeah, I can go to blue, I think. Okay. In the blue one, when you have a plus 2, now when you do this and get 1, what do you do to that amount? You make it 2 more, and now it's at 3. Every output is 2 more. So look, take this point. Isn't that one 2 higher? Take this point. Isn't that one 2 higher? I'm trying to do the obvious ones. Take this point. Isn't that one 2 higher? And honestly, no matter where you go, that one is actually 2 higher. Any point that may not look like it, but the next one is 2 higher. Every on a vertical line, every point of the blue is 2 more than the red, because didn't we added 2 to every output. We added 2 to every output, made the thing go up 2. If it would have been a negative 2, we'd make everything go down 2, because we take away 2 from the output each time. So again, the input is the X value. So input 0, output 0. But now when you do plus 2, input 0, output 2. Input 1, output 1, but now when you do plus 2, output 3. Output 4, but now we're outputting 6. Right? Every output is 2 more. That's what the plus 2 does. All right. Now I don't know how to get rid of all this stuff. But the period is just about over. Let's see. We'll finish this one. Let's go to B. Let's go to B. And what are you expecting this one to do? So now we're looking at y equals x minus 3 quantity cubed, right? What are you expecting that to do from the red one, the base model? You're expecting it to 3 to the right would be what you're expecting. Well, let me do it. No, I'm on Smart Ink. Where's my select tool? I think that will work. Will that work? All right, get rid of the garbage. Get rid of the garbage. Get out of here. I want to select. It keeps giving me the garbage, and I can't get to the garbage can. There we go. Hey, beautiful. All right. Did the function from the red one move 3 to the right? Yes. And I'll have to come back to this one tomorrow to really think about this one. But an input of 3 gives the same output as an input of 0. Because you took 3 away from it. 3 minus 3 is 0. That's why it moved that way. All right, that's tricky. We'll talk about it tomorrow. I'm quitting there.